Alright, so these are going to be our section of notes here and practice problems for Unit 7. The focus here is going to be linear model. Alright, first set of notes here, we're going to work through about this first page together, and you guys complete the second part as practice. So reminder, slope-intercept looks like y equals mx plus b. So the key idea is understanding how much each variable represents or what it represents. For b, this is like a one-time cost or an initial cost. M, we're going to see the word per. So this might be per hour, per item we buy. The key idea is per means it's multiple times, so that's always our slope. X, our independent variable, is like a number of items. Or it's the thing we're counting, how many times we're doing it. Y, we're going to think of as like a final cost, or like the outcome dependent upon the X variable. Alright, so first step here, let's jump in number 1. You and your friends plan to attend the county fair this weekend. The admission to the fair is $5, and the cost per ride is 50 cents. Let's go ahead and see what we know from that sentence. So, I paid $5 for admission. I'm going one time, so that's a one-time cost. That's going to be my B. The cost per ride, 50 cents. So I see the word per, so that means my M there is 0.50 for that 50 cents. So we can get our equation from just these two pieces of information. So it'll be y equals 0.50x plus 5. In our last sentences here, your parents gave you $20. Write and solve a linear equation about how many rides you can go on. So y we talked about being a total or like a final cost. So to solve, this means I'm given $20 for my y, and x is the number of rides I can go on, because it's 50 cents per ride. So solving, so the two things I'd like highlighted in this answer here are our equation, as well as our final answer, so I can go on 30 rides. Take a second and read through number 2. Okay, so, second sentence. The ranger charged $6.50 per hour. So I see the word per, I know that's my M. And then a $25 deposit. That's a one-time cost. So our equation, now the solving. You wish to rent the canoe from 12 to 3:30, or 12:30 to 3:30. Write and solve to see the total cost. So I'm solving for the total cost. That means I'm solving for y. Here, from 12 to 3, this represents 3 hours. So if I plug it in, I'm plugging in for my x. Our answer, so to rent that canoe for 3 hours, it's going to cost us $44.50. Take a second now and read through number 3. Alright, so here we got our initial value, or how much we paid for that car. So that's like my upfront cost. Now, it's going to depreciate. Well, depreciate means go down. So here my slope So it's saying per year is going to be negative 3,000. So our equation, y equals negative 3,000x plus at upfront or initial cost. And again, it's negative this time because it's going down. It's depreciating. Now for solving, we want to figure out how many years. So x is my number of years because it's that per year. So until we're worth this much. So that's my worth, and it's equal to my equation we're going to solve for x. So here we got our equation. We find out that in about 7.5 years, that's when the value of the car is going to be $3,135. Take a second now, read problem 4. So, we're buying a car wash at the gas station for $5. So that's a one-time cost. It's our B. In each gallon, per gallon the cost, that's my M, $3.10. So for our equation, we're here. Now, I have $40, and I want to figure out how many gallons I can get. So X is my gallons, because that's a cost per gallon for X. So I have 40 equals So here, we can buy about 11.29 if we round gallons. The rest of these problems will be left to you to solve. So you're working on numbers 5, 6, 7, 8. Once you've completed those, we're going to go ahead on to notes 2. Okay, now we have the standard form word problems. So standard form, ax plus by equals some number c. So a, b, and c are just constant terms. They're numbers. Alright, x and y are variables. So for number 1, Sam ordered 2 tacos and 3 enchiladas for lunch at the restaurant. His bill was $7.80. If enchiladas were $2 each, write and solve a linear equation to find the cost of each taco. So here, first thing we need to do in these problems is we're going to define our x and y. So, in each of these problems, you're going to be given like 2 different things you're talking about. Now, let's think here what we have. So it looks like we're talking about tacos and enchiladas. So we're going to have x be, since we know how many we bought, the cost of tacos, and here, the cost of enchiladas. So let's say I bought 2 tacos, so that's 2x, 3 enchiladas, 3y. It says I spent a total of $7.80, so C here represents like our total cost, or total profit. Now, they're giving us another piece of information. Enchiladas were $2 each. We said Y was the cost of my enchiladas. So now I can plug in. And at this point, we're down to 1 variable, so we can solve. So, it looks like tacos were about 90 cents each. Take a minute now, read number 2, and try and figure out what the two things we're talking about are, our x and our y. So we have tickets at a school play costs $4 in advance, $5 at the door. So this time we know the money. So x and y are the number of advance tickets and the number of tickets we buy at the door. So our equation, there are 4 for each advance plus 5 for each at the door equals our total. We got 440. Now, it says if no tickets were sold in advance, let's find out how many are at the door. So no tickets, that means our x is 0. Solving. Well, 4 times 0 is just 0. So it looks like 88 were sold at the door. Take a minute now and figure out your x and y for 3. You'll notice this information usually comes in the first or second sentence. So here, we find out her piggy bank has all dimes and quarters. So, we'll have x be the number of dimes and y be the number of quarters. Again, you'll notice I'm just defining these in the order they come. Okay, so a dime, that's 10 cents. So it'd be 0.10 x plus quarters 25, so 0.25 y. Looks like we have a total of $11.40. Now, it says Karen has 36 quarters. Well, quarters is my y, so I'm going to plug that in. Solving. So it looks like we have 24 dimes. Take a minute now. Figure out what your x and y are going to be for number 4. So here we're selling solid gift wrap to earn money. Solid color gift wrap, 4 per roll. Printed gift wrap, 6. So let's call this our solid, and this our printed. So we have 4 per roll for that solid, so it's 4x, and 6 for the printed. Now, we earn a total of $2,340. Next, we got the band sells 340 rolls of the printed, so that's our y. So if we plug in, now we can solve for x. So it looks like we got 75 rolls of that solid color. For your practice, go ahead and complete the rest of the problems on this page. Once you've done that, we're going to move on to 3 for some more notes. Now we're moving on to point slope word problems. So this is a formula you definitely want to write down on that note card. Alright, key ideas here. The information presented is going to be a little different. We're going to get an example scenario. So when we're given an example scenario, that's when we know we're going to use point slope form. So what I mean by that, let's look at number 1. So at Eagle Bay, it costs $10 per hour to rent a canoe. So I'm also going to be given a slope. So I know my slope here, or my M, is that $10 per hour. Nick and his friends rented a canoe for 3 hours and paid $45. So our example there, they're saying, here's an example of how this equation looks. For 3, it cost me $45. So when we're given this type of information, that's when we're going to use this point slope formula. Here, y and x are our variables. y1, x1 are this ordered pair we're getting. And m we're also going to be given as our slope. So here I have that equation. Now, what we're going to go ahead and do is we're going to need to solve. We're also told he rented this canoe for 8 hours, so that's going to be our x. So if we plug in simplifying our right side here, because those are all just going to be numbers, we arrive at our answer. Take a minute now and try to identify your slope in your example scenario in number 2. So here it's costing us $15 per hour. In my example scenario is for 9 hours, it was $195. So our equation now we're going to figure out a linear equation to find the one-time fee for the trash compactor. So we're trying to get this to figure out what B would be. So if we want to find B, that means we need to get into slope-intercept form. So to do that, I need to get y by itself. So first, I'm going to distribute on my right side. So 15 times x, and 15 times negative 9. Now to get y by itself, so that one-time fee is the b in my equation. So $60 is our one-time fee. So with these problems, we're going to be given something to plug in for x or y, or we can be asked to find, hey, what is that one-time fee? So that means find b. Number 3, a company offers premium cable for $39.95 per month, plus a one-time setup fee. So we know our M is 39.5. The total cost for the setup in 6 months of service was that. So again, here's my example. We're going to figure out the total cost for 2 years of service. So our equation So we want 2 years of service, so my x is 2. So simplifying that right side, we could just type in the calculator or GeoGebra, just how it looks. So my cost there, 184.8. Our last example here. A home security company provides security systems for $5 per week, plus some initial cost. So my M, 5. We're going to get our example here for 12. It cost me $210. And again, it's saying, find the cost of the initial fee. So I want to figure out, just like in example 2, what's B? So let's start off with our point slope. And again, we're trying to find B, so we're not given us something to plug in. We just got to solve it and make it look like a slope-intercept one. So as you guys probably heard, my daughter was at the park and found a baseball, so she was super pumped. Back to our problem. So we're in distribute here, so that gives me 5x minus 60. So we're in slope-intercept, so my B here is 270. So that is my initial cost. Once you've completed these, complete the rest of the problems here for your practice. Once you've done that, you can move on to 4 for some more notes. Alright, for 4, here, we kind of got 2 points. So we're given 2 example scenarios. So we're going to work through finding the slope, M, then we're going to find B. So, 25 minutes costs $7.25. 40 minutes costs $9.80. These problems, even though they're a bit more work, are pretty easy because they're skills we've already used. So finding my slope, the difference in the y's. Again, if you haven't memorized this formula yet, totally fine. Definitely a note card item. And again, if you go ahead and type this in GeoGebra, just how it looks with those parentheses. Here, we're going to find our slope. It is 0.17. For the word problems, we can go ahead and use decimals for our slope. Just round to 2 decimal points all the time. Now, I have my slope, so I need to find B. So this would be like part 1. Now part 2 would be taking either one of these points. So I'm just going to use the first one. So my x and my y are 25, 7.25. You can use the second one as well. And your m we just found is 0.17. So now if we plug in to our y equals mx plus b, we can solve for b. Multiplying these two terms first. And subtracting to isolate our b. We'll find here that b is equal to 3. So our equation, y equals m x plus b. We're not quite done yet. You'll notice it's asking us to say, write it and solve a linear equation to find the cost for 1 hour. So my final step would just be plugging in 1 here for my x. Calculator, we find out that cost is $3.17. So the two answers would be our equation here and our answer here. What we're going to do now is go ahead and do one more example together. Okay, so getting our 2 points, we have 100 degrees Celsius and 212 Fahrenheit. Our next one, 0 Celsius, 32 Fahrenheit. So, step 1 again, let's go ahead and find our slope. here we get a slope of 1.8. And again, for these problems, decimal slopes are fine. Step 2, let's go ahead and use this first point here again for my x and my y. And I know m is 1.8. So now I can plug in to find my b. And again, if you're feeling a little bit lost on solving these equations, the best place to go would be Unit 2. So now we've got our equation, y is equal to mx plus b. Now, it's saying it's going to be 25 degrees Celsius. Well, we wrote Celsius as our y's. Or I take that back, we wrote Fahrenheit as our y's because it was the second thing listed. So Celsius represents our x. So here I'm going to plug in that 1.8 for my Celsius of 25 and figure out what the Fahrenheit is. That gives me 77. So these would be the two answers we're looking at here. And again, to get which way you plug in, it's all about the order you wrote it. I write it in the order they give me. So Celsius, Fahrenheit. So Celsius is like my x, Fahrenheit's like my y. At this point, you guys can go ahead and finish up the rest of the problems on 4. Once you've done so, move on to 5 for some more notes. Alright, so 5 here is going to act as a review for us. What we're going to do is do this first page together. So you see I've already wrote in what each one is. And we're going to talk about how I know. So here, for 1, so it's kind of combining all 4 of the first sets of notes. So for our first one, we were buying $48 worth of 2 types. Anytime I get like 2 items I'm comparing, so 2 different types of cakes, seeds, 2 different types of cars, that's always going to be that standard form. I'm giving an x and a y. So we have ryegrass lawn seed in fescue. And we know how much they each cost. So this represents the number of each. So from here, let's go ahead forward and work with our equation. So let's see, okay, so I have, it's 70 cents for each of my x's, and $1.15 for each of my y's, and I spent $48 total. From there, let's go ahead and move on a bit. So now, we know that we got 25 pounds of fescue, so that's my y's. So I can go ahead and plug in. Multiplying that 1.15 times 25. Subtracting. And dividing. So we get 27.5. So that would be our answer there. So 27.5 pounds. Number 2. Jeff is keeping track of his weight over several weeks. After 2 weeks, he weighs 194. After 6 weeks, he weighs 186. This looks like we're going to need to get to y equals mx plus b, but a shorter way is this is a 2 example problem. So, I got after 2 weeks, I'm 194. After 6 weeks, I'm 186. So again, since we weren't given a slope, there's no way I can go right to y equals mx plus b. So if we go ahead and start solving here, finding my slope, we find out our slope here is -2. Finding my b. So I'm just going to use that first point here for my x and my y. M is -2. And again, if you had used the second point, you'd arrive at the same answer. So b is 198. So for our equation, we got y equals mx plus b. After 12 weeks, well, that weeks we seem to put first as our x's. So I can go ahead and plug that in now. So that gives me 174. So these would be my answers here. Now this one, here's why we could see this one's kind of our easier one. So a landscape supply business charges $30 to deliver mulch. Well, that's a one-time fee. And the cost, $23 per cubic yard, so there's my M. Well, I already have that M and B, so I can write my equation very quickly. Now, 8 cubic yards, well, that cubic yard thing, that one with our x, because that's dealing with our slope, so I'm going to plug in 8 there. So our answer, y is equal to $214. For our last one here, if Karen used a birthday check her mother gave her to start a savings account, she plans to save $25 per month. So we got a per, so I know I got a slope. And then I have one example. So what that means is I'm in that point slope type form. So writing our equation, now we're going to write and solve when we're going to find the original check. So original is like starting. So what we need to do, we got to find what B is. So distributing over here, adding to get y by itself, so I can identify B. So our B is that constant term at the end here, so our B, our original check, was for 50. At this point, go ahead and try the next set of problems. I would suggest identifying which type of problem each one is first. Once you've completed that, we're going to move on to 6 for some more notes. Alright, so we're looking at 6 for our first notes. Okay, so here we're working on some little linear modeling. So we're going to be given some example problems, and we're going to work through them together. So we're going to do the first 2 problems together, and the rest of these will be left as practice. Alright, so for our first one, real world application 1. So just some quick vocab here. X is always going to be our independent, Y is our dependent. So the independent is a change in your experiment that you can control, so that you're measuring against. Y, it's the outcome. It's what we're going to see our independent effect. So you're visiting downtown Chicago and a taxi company charges a flat fee of $3 for using a taxi and 75 cents per mile. Let's look at our variables first. So the slope here is going to be that per hour cost. So that's 75 cents is going to be our per hour slope. The y-intercept is our flat fee of $3. So for our independent, that's our cost per mile. And our dependent is the flat fee. So here they want us to write an equation to find the cost C after m miles. So using the variables they give us, well, our cost depends upon how many miles. So it'd be 0.75 because that's my slope, plus that $3 flat fee. How much for 8 miles? Well, let's see. That's giving me my M. So, calculator, or GeoGebra, again, type it just how it looks. We'll find out that that's going to be $9. Here they're giving us a cost, so it'd be 15 is equal to 0.75 M. And we're going to find how many miles we drove. So if we divide both sides here by 0.75, we'll get 16. Moving on to our next example. An airplane 30,000 feet above the ground begins descending. So it's going down. So that's a negative slope here. Feet per minute. Assume the plane continues at the same rate of descent. Let's look at our variables. So M here is that negative 2,000. And what it represents is that descending rate. The y-intercept would be 30,000. That's our starting height, or our initial height. So an equation, the elevation just means height, after it's been in the air for m minutes. Well, that would be E equals negative 2,000 m plus our initial height of 30,000. Altitude, so that, again, that elevation after 5 minutes. So I'm plugging in for m. It says m is my minutes. So there, you should get 20,000. Moving on, it's saying now we're at 8,000 feet. How long it's been descending? So we're finding our minutes. So it looks like the plane's been going down for 11 minutes. Once you've completed this, finish the rest of the problems on this page for your practice. Once you've done that, move on to 7 for some more notes. Alright, for these, we're actually going to go ahead and skip over this table a tad bit, but we are given some points, so we'll write them in. Okay, in 2008, Billy Bob purchased a car for $18,000. So in 2008, he got the car for $18,000. By 2013, it depreciated to $10,500. Now, the reason why I left this age in cars blank, so we're going to always treat our first point as the year 0. So, 2008 we'll treat as a 0. Age of the car in years here, 2013. Well, if I subtracted these two, 2013 minus that will give me 5. So at this point, the car is 5 years old. We're not going to worry about graphing these. The key idea here is our independent x, that's always dealing with time, so that's the age in years. The dependent, well, we'll go with the value instead of the cost. Either one will get you the same idea. So our 2 points we're going to use are 0, 18,000, and 5, 10,500. Now, it's time to find the slope. So what that tells me is this car is going down by about $1,500 per year. The initial value, that means find B. So if I choose, let's say, this point, so I'm using this for my x and my y respectively. My m we found is negative 1500. So plugging in, oops, my m was negative 1500. X is 0. So 18,000 is going to be our b. So this linear model, the value of the car v after n years would be v equals my slope. It says after n years plus that initial value of 18,000. So my model, if when the car is worth nothing, set me a value of 0. And we're figuring out how many years that would take. It's saying when. Dividing at the end. So it looks like after about 12 years, that car is going to be worth nothing. Here, we're going to have pretty much the exact same steps, so we'll just go through the first parts here to kind of get our independent, dependent, and those different variables. So we have Gemma as a sales clerk in a jewelry store. Although she receives a base pay of $10,000, the rest of her pay is determined by the value of merchandise that she sells each month. In February, she sold $12,000 worth of jewelry and earned $1,960. In March, her pay fell to $1,720 because she had only sold $9,000 in sales. So here, our independent is the sales, because that's what we're really going to kind of change. The dependent is her salary, or how much money she makes. So, our 2 points here, we have that base pay amount of $1,000. We got some examples going on here. So what we really want to figure out is our slope, how we're going to change. So let's think here. We got our 2 points, right? So if I sell 12,000, I earn 1960. So 12,000 goes with 1960. 1720 in my earnings. Oops, wrote these backwards. So our earnings, let's go back to how we define this. So our independent is how much we're selling. So that first one was good. 12,000. And we earned 1960. Here we got to make sure, so it said we sold 9,000 and earned 1720. So just pay attention to the order you define your variables. Finding your slope. We get an answer of 0.08. So she's getting about 8% pay for those sales. Here we're finding the y-intercept. Well, if we pay attention here, we figured it out already. She gets 1,000. So here, B is just 1,000. Or you could calculate it out. The linear model here would be P is equal to that 0.08. And it wants D dollars in sales plus that initial salary. Now, if she sells 14,000, well, that'd be P 0.08 times 14,000 plus 1,000 plugging it in the calculator. Looks like here her pay would be $2,120. At this point, you're good to move on. You'll be finishing the rest of these problems as practice. Once you've done so, you can move on to 8 for one of our last sections of notes. So here, we're going to do one more practice problem together. So we have a company that manufactures surfboards has a fixed cost of $300 per day and an output of 0 surfboards, and a total cost of $5,100 for an output of 20. So our independent here, the thing that's going to affect it, would be the number of surfboards. So our independent is always the number of things we're selling or how long something takes. The dependent is usually a cost or how much we're going to make. So here it's that cost per day. So our 2 ordered pairs, well, for 0, it's 300. For 20 surfboards, it's 5,100. Finding our slope or our rate of change. We get $240. So it's costing us about $240 per surfboard. The initial value. Well, here it's saying at 0 we get 300. So you can either go back and see how to solve for that beef, but you'll notice anytime when we know what the initial cost here, so a fixed cost or a flat fee, or here we basically, if you have X is 0, whatever goes with it is going to be your beef. So now our cost C, so it's $240 per surfboard N, plus that initial cost of $300. We're not going to worry about graphing this. Okay, so find the total cost for an output of 12 boards per day. Well, that would be C is equal to 240 times 12 plus 300. Which gives me 2,910. Here, they're giving us our total cost, so we're solving for that N. So subtracting 300. Dividing. So this would be 15 surfboards. At this point, go ahead and complete the rest of these practice problems. Again, don't worry about the graph. Once you've done that, we're actually going to skip over 9 and 10, and I'm going to do some problems directly off the review. They're related to scatter plots, but I figured that would be the best method of showing you the key ideas here, and without costing you an abundance of time on this unit. So here, I'm going to go ahead and jump on the review and look at a few problems. Again, we totally skipped 9 and 10. So let's see here for some scatter plots. Okay. So, correlation. Essentially, if it's going down from left to right, it's negative. That just means if I drew a line, it'd be going down. If I look at C, well, this is going up, so this is positive. Correlation just means, like, what's the slope look like? Here, it doesn't look like there's any pattern, so this is no correlation. It means the data doesn't really have anything to do with each other. Here, same thing, it's not going up or down. Looks like it's going down and then up, so we're going to call that one no correlation as well. So again, just having a general idea about positive, negative, or no correlation. Okay, which relation is shown by the scatter plot? Well, okay, so it looks like as the cost of the flight goes up, so as cost goes up, the number of them that are being sold is going down. So sold goes down. Well, that's choice A. So again, just kind of rationalizing what happens. As your X gets bigger, what's your Y doing? Okay, which one here makes sense? So, let's see here. Let's start with D. So this is saying as the price goes up, clothing are sold goes up. That doesn't really make sense. So no, that's not an answer, right? If the price is going up, you're probably going to sell less things. Okay, cost of sunscreen. So as it's going up, so as cost goes up, it looks like swimming, there's really no correlation here. So since there's no correlation, not our answer. Next one. Here, plane ticket cost. So as our cost is going up, the people going to Hawaii, so tourists also go up? That doesn't make much sense to me. You'd think if plane tickets were cheaper, more people would go. So no. Here, amount of copies made. So as your number of copies goes up, it's saying the ink is going down. Well, that one definitely makes sense. The more copies, the less ink you have. For 8, the scatter plot below shows the average yearly consumption of bottled water per person in the United States starting in 1990. Using the trend line, so the trend line just means this line that they drew in the graph. Let's see how much bottled water was in 1997. Well, 1997 would be between 96 and 98. So if I go up here, and I'm looking at my trend line, it looks like about 16. So again, just making a conclusion from the line. Here, we'll take a look at, that one we should be good. We'll take a look at 9. A high school principal wants to predict the number of students who will drop out of school. So he's got an equation. The key idea is years since 2004. So the first thing we're going to do, just like earlier, is rewrite these years. So that's the number of students, but the years since 2005 means 2004 x's are 0. Now, we're looking at 2015. So, if I think about that, between those 2 years, I would subtract them then to get 9 years. I lied. 11 years. So that 11 is what I would go ahead and plug in here for my x. So that would give us an idea about how many students dropped out. Equation of the trend line, well, we have 2 points, so I'm going to use those. We're going to find slope using the slope formula, and then find b by plugging into y equals mx plus b. Figure out your equation, and it's similar to what we've done. Same thing here. So are they on the trend line? Let's look at these points. 125, 163. Well, it's here. 163. That doesn't look like it's on that line, right? Because that's pretty close to 200. So that would be false. 80, 70. 80 somewhere here. No. That's the, or 8700. Yeah. Maybe? But not definitively. So if they're not blatantly on the line, the answer is false. Positive correlation? Well, from left to right, that's going down, so that's definitely negative, so that'd be false. And these should look like all these word problems we've done. So at this point, you should feel pretty comfortable with everything in here, so go through this review a couple times, and after that, once you checked it in, all you have to do left in this unit is pass that Unit 7 exam.